Turn that up, okay. We're upside down, we're upside down. There we go. All right. Okay, today we are scheduled to do the quotient rule and scientific notation. Scientific notation is not a big deal. And if you look, this is all we have left of this semester is chapter 3 sections in chapter 6, and that'll be it. But tonight we're going to do these two items. I'm going to start with 2.3. Before I do that, are there any questions and homework that I've assigned so far? No? Let's take a look at this one. This is the textbook for 2.2b. All right, let's go and take a look. So if we go scroll down through this. So it says use 0 as an exponent. So we had rule for 0. Let's take a look at what the rule is. There's our practice. Negative exponents, we did those. So like these kind of rules. Do you see how it's in blue and everything? These kind of rules you're going to want to have. Notice, do you see how when they're negative up here? See this one? What happens to it when it drops down? So this is our negative exponent rule in a more advanced version of it, you could say. So yeah, each thing will have something, each kind of rule will have a box around it like that. These are the practice problems now. So look for things like that, definitions. That's what you're looking for. Although they don't specifically, explicitly use 0, they don't tell it, say anything to the 0 as 1. What's this? What happens? What are these? I mean, you guys know? 1. Oh my. What did that do?
Say it again.
I don't know what happened. Wait, hold on, let me find where I was at before I go. Did it close the book on me? No, I clicked this thing. I was wondering if you guys knew what that thing was. I don't know what that is either, so. But yeah, stuff like that. Let's see if we can find any in the previous section. 2.2a, see this right here, definition. So you're gonna look through that, write them all down, maybe on one page to have them handy. And then use them as you're doing homework perhaps, so you can, if you refer back and forth to them, by the time you've done all the homework, you'll probably be pretty efficient with it. All right, so let's go ahead and do the quotient rule. Well, here, while we're at it, let's find the quotient, what the actual quotient rule is. Here's what it says. So I will pull the quotient rule right out of the book then, so we can see. Let me get this name in our thing today. Basically, it's one rule, and then we're going to do a bunch of problems to practice that rule. I'm doing this in two parts so I can expand to this thing to a larger size. So this is the one rule we're going to make use of constantly. I'm going to add to the quotient rule. I'm going to see if they add to it too. Let me know when you're done writing. I'm going to add to it. But we'll see if they add to it as well. So I'm going to scroll through and see if they got another box. They do not, so I will add to the rule myself. This rule can be stated in more than one way. Use whichever way is convenient to you. This also equals 1 over A n minus m. Look, be careful here. You may not realize this, but that thing up there is the negative of that. That's why this one's up and this one's down. What's the negative of the other? So either one of these is going to be useful. You quick examples to illustrate when you might do it. Let's do A to the 9th divided by A to the 5th. According to that rule, remember, you're going to be given a bunch of problems and they want you to have nothing but positive exponents at the end. These exercises are to develop skill in the manipulation of these things. So according to the rule I'm going to use, the way I would work it is since 9 is bigger than 5, I'm going to take the subtraction up here. So this is A to the n. Well, I would say A to the A minus 5, doesn't it? A to the 9 minus 5, which equals A to the 4th. Now, I'm going to do this in 2 steps. What if I change this to the following? Suppose I have x raised to the 5th power divided by x to the 9th power. See, now you use the rule, just the one rule they gave you. Wouldn't you? Then that equals x to the -4. Now, since you're supposed to make it positive, what do you got to do? What's the next step that you have to do? Put 1 over x to the positive 4. Now I'm going to redo this. Second way. If instead I could have done this all in one shot by simply noticing that the 9 is bigger than the 5, and I could have simply gone like this. See? And I avoid having any negative power. It doesn't matter. You can do it in that way and always make it work, or you can do it this way. I'm just telling you have the options here to help you out. And the goal will always be to try to get a positive exponent. So we'll go through a variety of problems that illustrate exactly the rules that we have. And I think it is a good idea to write down the list of rules and have them handy while you do your homework. That way they become, if you write them each time, they'll become ingrained in your memory without effort. Are there any questions? Should we start? That's it. I mean, that's the preparation material for what you need. All the rest is problems thrown at you. There's no extra material or anything. I'm just going to do some problems here. course, they're making the assumption that none of these letters are equal to 0, so you don't have to worry about dividing by 0 or anything like that. So this will be pretty much the direction for all the problems we're going to do here. We'll go over the easy ones hopefully pretty quickly, and then we'll go into the serious ones. So take a second and see if you can get that.
So,
That's right. Well, 11 minus 7 is not 5.
I mean, I'm sorry.
So you should have gotten Z, the 11 minus 7. Z to the fourth. Now what if I switched on you? And I gave you Z to the 7 divided by Z to the 11. Now what would be your answer? No, you gotta make it positive.
1 over Z to the fourth?
That's right. You can positivize. Make it positive by bringing it down below, right? But see, you're doing it in 2 steps. Here's what I'm gonna do. Look. Bigger minus smaller. So I avoid, you don't have to do this, but obviously I'm advocating for it because it saves you a step. It also, if you're able to do that, it makes sure you're aware of what the exponents are. You have a feel for them instead of trying to just apply a rule that you don't have any feeling for. Good? Are we good? Okay. Just real quick, can anybody tell me what number 18 is gonna be? 8 to the 5th, because that's an 8 to the 1 down there, isn't it? Now, the numbers are not gonna really do anything, but I'll throw one in there just so we know that we're not gonna have any difficulties. So what do you think this is gonna be? When it's done, what do you think you're gonna get? Yep, 4K to the second. So having a number attached to it is no big deal, right? That's all I wanted to get at. Sometimes people conflate these numbers out front with exponents, and that always is not good. So here we're gonna have 4K to the 4 minus 2, which is 4K squared. Right, you got it. So you can see that they're doing a little more complicated.
So it's got 1 to the, negative 2 to the second.
What's the -2?
is it, is the answer? Cause since we got 8/8,
Hmm.
is that?
8 is the base. 8 is like X. Okay.
So I can put 1?
No,
No, just.
no, you can't do, no. You use 8.
Do the second time,
What's the answer? Tell me your answer.
that'd be 8 to the second power.
64? The answer is 64. Anybody else think?
1/8 to the second, which is
1/8 to the second.
Okay, we want to see 8.
larger, so you can do it in two ways, remember, if you just use the one rule, this is how you can do it. You can do 8 to the 4 minus 6 if you want to stick with just one rule. But then when you get to this point, that's not going to be the answer. That's positive, they're not going to accept that. So you're going to have to change it to 1/8 to the second power. I don't care if you evaluate it, if it takes that as the answer, let it be, but it is 1/64 if they require you to evaluate. Or, let me do this and then you can ask your question. You could have done this. Because the larger exponent was in the denominator. See, I have one last step there.
And that's pretty much what I was gonna ask, because I thought that we would have to say, you know,
Yeah, you, just whoever has the larger exponent is how I work. That way I'm running to a negative exponent, but a negative exponent is not a big deal. If you have a negative exponent, you just put it below, make it positive, wherever it's at, and change its position, and change the sign.
These do get pretty ridiculous. You'll see as we get near the mixed exercises. Same directions for all of these. Positive exponents only is permitted. Now, in your simplifying, don't forget to simplify the 35 and the 56 also.
But it becomes,
Right?
to the fifth power,
What to the 5th?
T to the fifth power.
Right. So 5t to the 5th divided by 8. Did you guys get that? 5t to the 5th divided by 8. Let's take a look.
So as far as the numbers are concerned, I can cancel 7 goes into both 35 and 56. So 7 goes into 56 8 times. So I've got that. Now what I do is I look at it, the bigger exponent is in the numerator. Right? So I'm going to subtract, I'm going to divide out this one here and put a -2 up there. You guys with me? So put the -2 up there.
Oh, yeah.
That's what's nice to make use of the rule. So now let me write my answer down. I have 5t fifth divided by 8. So that's how your answer would look at. If you take that in.
This is when they start to get enjoyable. Look at this thing.
So whatever you do.
Don't say anything. Let everybody give it a try first. Whenever anybody thinks they got it, let me know.
You too. Negative 29.
No,
So one over you to 11?
whenever you to the 11. So it's I have at least 3 ways to do this problem. Should I do them all 3 ways or just? Okay, that's what you want.
I don't know, I know you're, some of these ways are convoluted, so, well, the one rule, we had one rule from the last section that said you can simply do this. U to the 9 divided by U to the 20. Just you just simply switch the positions on everything. And now you can use the rule that I've been using, you can do, 1 over U 20 minus 9. Like that, since the larger exponent was in the denominator. So we end up with 1 over U to the 11. Now, I'm going to give you another way, which is using just the one rule. Let me pause while I'm even so now. Now, what if I use just the one rule? Just the one rule says this. Says that I simply take the exponent in the top and subtract the exponent in the bottom. You guys with me? You guys all follow this? What happens to those double negatives? That's the positive, yeah. U to the negative 11. But now you know what to do with that, don't you? What does it become? 1 over U to the 11. So you can literally just use the rule, the one rule. You'll get, sometimes you get a positive exponent, sometimes you get a negative one. Either way, you should know what to do next. You get a positive exponent, you're good. Nothing else to do. Negative, you gotta do that too.
Are we good? All right. How bad do these get? See this? Look at these horrible things. We've done some of those. Let's start when we have multiple variables. So with this one here, here's what I would do if I were doing it by hand. In front of it. I would rewrite it. I always am a big fan of rewriting things in convenient ways. So here's what's going to happen. The p variables are going to work together. And so are the q variables. So look here, I can use the rule for each of these. I can cancel out p squared by putting a -2 up here.
Agree with that? I can do the same thing with the Q. I can take out the Q to the third by subtracting the 3 up there. And so what am I left, what do I end up getting for my answer? P to the third, Q to the fourth, P to the third, Q to the fourth, exactly right. So that's the nature of this game. No matter how many variables are there, just they work together. They call them, what do they call them? Like terms. So you're canceling like terms is what you're doing. Like variables. Now that's even better, I think. So let me give you, oh, look at this thing. All right. These rather gruesome looking ones probably are going to take us a while. When you think you got it, let me know. I'll come by and check.
That's the only.
What's the what part? Well, let's start with the numbers. Did you calculate the numbers? So we can knock out the, like the point. So the way I write these out is I give myself lots of space for writing things. I'll do 28. U to the -2. Here, I have 14. E to the 5th. U to the -9. Here's the way I do it. I'm gonna put this here. Okay, first, let's cancel this out. Good. Now I'll take this guy out by doing the following. See how I put it below? Now I can take this guy out.
So that's 2T. That's 2, T to the 4th power. U to the 7th.
So we have 2 on the top, U to the 7th, that's right, over T to the 4th. That is not the only way to do this problem. So you could have, for example, you could have rewritten the problem with no negatives at all. You understand? So you could have put the negatives all out of your misery right from the beginning, you know what I mean? You could put that U to the 9th and then U to the 2nd, and you wouldn't even have to deal with that. You guys know what I'm talking about? But you could have done this, started off just something like this, 28 T U to the 9th over 14 T to the 5th, U to the 2nd. You could have done this. So say that all positive, then you got rid of the negatives right off the bat. So in this stage, I would still do what I did. I would still cancel everything like I did. Like this, I would still do -1 there, but then here it would look like this. And that 9 minus 2 is exactly the same as -2 plus 9. So then we get the same thing this way as well.
down here. Too fast.
Is it 10?
Mhm.
So,
Think you got it?
so. That's not- where's the one?
I don't know what. What do you?
Hey, no. So, 63,
Three times, eight to the.
yeah.
You know,
Okay, so I reversed it, but I had a negative, okay,
Mhm.
so I had 63. 87 square.
What happened to the 7?
I put it, I reversed it. Okay, if it's a negative thing up here, so I reversed it.
no,
No,
instead of here,
it was,
7, pretty good.
I did that was 76.
That's a one.
No. I mean, it's good. I got 9 to the 4th power, B to the 6.
Now, what you can do, I'm gonna do this in different ways, just so you can see that there's more than one way to do it. 7 goes into 63 9 times. Now watch what I'm doing here. You can do every problem like this. Do I get it? Apply the one rule. Now let's see what we get. 9a to the -10 to the -6. Do we know what to do with these exponents that are negative? Bring them down below. 9 divided by a to the 10, b to the 6. So remember the one rule, you can live by this one rule alone. Okay, actually two rules. If you have a to the n divided by a to the n, you can use just this one rule and then this rule. You can live just using those two rules for everything. So all the problems are gonna be messy like this from here on out.
I'll bring that back on for a minute. I'm gonna put another problem down though. So when you finish that, I put up another one.
So you wouldn't accept 9A24?
No, the 8th and 10th and read the 6th note has to look, it has to be what I have there. There's no other form for that answer. You think you got it? I can use some like,
Not to get the. As it, I was telling her, you can use just those two rules to get for everything. Not be any trickier than that. I was thinking. What I think I'll do is I'll try to approach them, all of them the same way from now on. That way we'll get one. But you guys will be fed one way of doing them. You think you got it?
So. Please.
That's it. First thing you should feed here to divide out is 3 goes into 18, 6 9. Let me start my fraction here. I'm gonna have 6 down here. Here's the way I do it. You can do everything this way if you want. A to the 2 minus negative 10. B to the negative 11 minus 6. What I'm trying to tell you is that using this one rule, you'll never get it wrong because you know what to do with it when you have negative exponent. Look at the A, look at the exponent on the A. What's 2 minus negative 10? Positive 12. That's 2 plus 10, isn't it? What do you get for this?
Say it.
What do I get for this part? What's that number up there?
17.
Positive or negative? Negative 11 minus 6 is positive 7.
Maybe it's the stuff. So why do you get to say it?
Well, whenever I subtract a negative number, I put parentheses around it. So now, what needs to move? Right, so that's just gonna drop. And we end up with a to 12 over 6b to the 17th power. Remember, the game is all positive exponents. But I'm telling you right now, you can use that one rule up there to do the whole problem. To do these problems. I don't know how many we got. Well, I got some odd ones I can grab too, I'm sure. So I don't think there's gonna be lack of practice. We gotta make sure we save some time for, scientific notation though.
Because you have, just track and go to the 9.
Right, they're not gonna be cancelable. I give it 5 times. We're getting minus, I'm just gonna minus it. That'll be the 10 positive 1 exponent. You're right, the 9 and the 4 cannot handle. No, just give yourself lots of space, and these won't be that big. The 9 and the 4 are just safe because they are raised to a positive 1 power, they don't get changed. Here, what I'm gonna do is x to the negative 5 minus negative 2. Then take that out down there. I'm gonna do it the same with the y. Y to the 2 minus 6. I get 9. What's the exponent? What is this number up here going to be?
7.
Negative 3. Negative 3. What about this up here for the y? Y is a negative 4. Then you know what to do with these things now that you're in this position. We end up with 9 divided by 4x cubed y to the 4. All lots of exponents.
Go, let me grab one on the homework. That would be a perfect place. I don't know what's in that thing. I don't know how, do the homeworks agree fairly well with the material on the, in the book? The homework's the same?
Yeah.
Okay. I never know, 'cause since I'm not a student, I don't get to see these things. So let's pop into the homework and see what's in there. That's two, what? 2, 3? 2, 3, yeah. Let me get this thing. So you have some fairly simple ones by now. That shouldn't be so bad. I just want to see how bad they can look. Okay, so your homework is 14 questions. However, it's 1 through 7 repeated. Do you understand?
Yeah.
So, yeah, so it's 2 sets of 7, so it's 7 totally different problems. So let's take a look in here. Do we want to do, well, yeah, let's grab one of these and see how you do. This is what you're expected to do on the homework. So let's go ahead and grab this. And see how you do with it. This shouldn't seem as bad as the ones we were doing here. I think I've done harder problems than what maybe you need to do.
Into.
8, yeah, that's right. So when you do it, right, so you can just, this one is not hard at all. You don't have to do any moving at all, do you?
No, just cancel it.
So the 8 goes into the 24 and the 64. I'll rewrite it so I have bigger word things. 24 D divided by 64 B C D. All right, first 8 goes into 24 3 times and 64 8, correct? Then you can cancel out the C and the D. That's pretty simple, right? So all that's left on the top is 3. And in the denominator, it looks like 8 feet.
Any questions about that? Nope, okay. Let's see how hard these get then. These don't seem that bad at all, do they? Let's let it go. Go ahead.
So what is that? 7X. 3, 4, 5.
Not quite. The bottom is wrong. Check it out. Yeah, it's fine.
Yeah, yet.
So it's 752, the.
Uh-huh. You want to get before? 9, you divide out 9, right?
It's fine.
9, goes in 63 7 times. If you ever get stuck, you gotta do this, don't you? 5 times 9 is 45.
Mhm.
So it's not 5.
Oh,
What times 9 is 54? 6, correct. I'm just on to this, I don't know how to do it, except I know what that is. Put 6 down here, and then we can do 5 minus 2. 7x cubed. Or 6. We're good? So that's a good thing, I guess we did much harder problems than I had to do. Look at that mouse. Do you guys know how to input these things? Do you need me to show you how to input something?
yeah.
Are you okay with it? Inputting? Okay. Let's see what 3 is. Okay, good. Then we are going to deal, now this switches to 2.4. This is scientific notation. So let's go ahead and go into that, and I'll explain the reasoning for it and all that kind of stuff.
So it'll be 10 to the 4th power.
Well, right, it is. Right, well, we'll get to that. Do I want to switch it in here? Go back here. Scientific notation is based on a power of 10. Your calculators have scientific notation built into them. Let me see if I got one. I got these things hanging around. Let me grab one of them. Let's see what you guys calculated. You got the same kind I do, I think. You. For today's lesson, I'm gonna have you borrow a calculator. I'll tell you. Don't lose these cards, by the way. If you ever bought it, these little cards will save your life. They come in, they have all the commands. Oh, for the calculator. Are they still putting them in or not? Yep. Okay, good, good. Let me see, where are we at? Let me see if I can find it. It's usually under some sort of a mode. You see, right out the bottom of the screen, look at the bottom right side of the screen, it says DEG. You see it? Yeah, you know what that stands for? Stands for degrees, which is a standard notation for trigonometric class. No, what we want, look at the top where it says DRG. You see psi n? That's the stuff we want. So what I want you to do is to put in the number 1 million. And it equals, just so that you have $1 million, 1 million on the screen. Don't do anything yet. Just hit 1 million and hit equals. So 1 million is entered on the screen. Everybody there?
So that's 16.
All right, now press second DRG, because you need to get to that seconded function. Go over to SCI. And hit equals to get out of the screen. You see what it did? One this 10 to the 6, right? So here, let me write this stuff down what our calculator system. Your calculator is using a notation the best it can, but I'll explain what it's trying to do. This is 10 to the 6. That is. Okay. So we have 1 million and 6 zeros. That does equal 10 raised to the 6th power. But so how do we explain this little business? So times thing. Do I have something like that? So it's telling you about 10 to the 6th power. It's trying to do it. It's an annoying notation. But what they're trying to write in your calculator is this. They are trying to write this notation, 1 times 10 raised to the 6th power. So scientific notation is always of this form. Let me do another one. Instead of 1 million, I'm going to do 23 million. Now, what you can do, scientific notation will lead you to try to do this. (23) with 6 zeros. This doesn't count as scientific notation. Scientific notation, the way it works, will only allow for 1 digit here before a decimal happens. Is that how you want it? I'll show you what I want. I didn't make up this notation, so I don't have any kind of a feeling one way or another. So this answer is not considered scientific notation. Let me show you what it is. This is considered scientific notation. On your calculator, enter 23 million and see what it says. Right.
She wanted exactly as calculator.
Right, because the calculator is programmed to correctly display scientific notation. So while you're in scientific notation, if I ask you to convert a scientific notation, it should be a cakewalk. Follow what I'm saying? Obviously, scientific notation has been made since when you're dealing with large numbers, scientific notation is quite useful. Can you imagine, I don't know, like this? Well, I had 20 zeros. If I have that in the calculator. See, it won't, after a while, you won't see the zeros being generated, so you're gonna have to just keep. You're going to have to, or there was 20 zeros, wasn't there?
Yeah.
This is 518 times 10 to the 20th. You can actually have your calculator do this, can't you?
Yep. 5.18 to the 10 to the 22nd.
So 10 to the 20th power. And my calculator tells me that too. This equals, do you see what it did though? You see where it put the decimal?
Yeah.
You're only allowed 1 digit and then a decimal. So it is 5.18 times, doesn't do 10 to the 20 though, does it?
10 to the 22nd.
Why do you think it's 22 now?
You have this.
I moved the decimal 2 places, which is like multiplying it by 10 to the 2nd power. Oh. So all these, when I give them to you, as long as you're in this mode, you're good. What do you think happens with tiny numbers? So scientific notation, for obvious reasons, is used by scientists. Like these monstrous numbers. Who would use monster size numbers? Space? Any kind of space stuff will involve gargantuan numbers. Because bigger numbers are our national debt. That's happened. 30 trillion by now. So large numbers are quite possible. Usually when you're dealing with gargantuan marine animals too, you know, these numbers are all giant numbers, billions of tons and stuff like that. So they might convert to this notation, or they might simply say, in the last example, they might simply write 23 and write the word million. You see what I'm saying? Because in a newspaper, they may not have the ability to do that kind of a font where the exponents, you know, they might not be able to do all that. But we also need very small numbers. For example, medicine uses tiny. Then you can think of bacteria, COVID, any of those things are very tiny. things you have to look under a microscope. And even tinier still, you've got the tiniest things in the world, electrons, and they break them apart, and they're even smaller particles than electrons. So these things can be absolutely tiny. So I'm gonna give you another one to write in your calculator. Oh, you're marking this one. Let's go the other direction. Watch what happens when we do this. I'm gonna do 0.1, 2, 3, 4, 5. And let's put a 5 here at the end. The 5 zeros and a 5. Signs. To setting signs and quick signs. Now, I think I've only got you doing conversions of these things. We're not actually doing anything. What was your calculator? You can do anything involved. Type this in and hit equals and tell me what you get.
5 times 10 to the negative 6.
5 times 10 to the negative 6. The calculator outputs 5 times 10 to the negative 6. And let's do the same problem, but do 5 zeros, 52. And tell me what you get. What does it do?
5.2 times 10 to the negative 6.
Once again, one decimal is only allowed. The rest of the decimals go here. But notice the 10 though. What's the exponent now? Negative. So
You have to,
if you were actually to do this by hand, you would have to drop that 10 to the 6 below, wouldn't you? So it's like dividing by a million.
would it be like 5.2 over 10 to the 6?
Right, so it would be, yes, it'd be 5.2 over 10 to the 6. That's an indication of how tiny this number is what I'm getting at. If you're taking a number divided by a million, it's very tiny.
How much of what minutes does.
You never measure particles solely by themselves, you measure them as a group. So like when they take my blood for cholesterol measurements, they will do it in milligrams of urine divided by deciliters of fluid. The total amount that they get versus, so they can't really, the particles like COVID, you could probably zoom in enough to see them. But like electrons, they can't. So all that they can do is kind of corral them and get most of them to do what we want.
I was on medicine for like, at one point, and then I used the same medicine for like acid reflux. Well, I got it. It was same medicine except it treated your body from percentages or like a milligram. I don't know.
Well, let me give you another example, how you work with small things. This here, notepad. Now you're asked, how thick is a single sheet of paper? Now, if you try to measure a single sheet of paper, it's impossible, especially with a ruler. However, if I measure the whole,
And then divide by,
and then divide by the number of pages. You see what I'm saying? That's how you do stuff like that. All right, so so as you can see, it's a tiny number. This would be microscopic. Who knows if it would even be visible under any microscope. So this is the notion of what you're going to be doing here is converting back and forth. Let's do a big number. Let's convert one from scientific notation back. How would you do it? So now, let's say I have one that's in scientific notation. We're going to convert 2.37 times 10 to the negative 9. The standard notation. This is the one that we would ordinarily use. You know how you would do it?
You would start with the decimal.
Type it in.
Oh,
Make sure you use the little negative button down there, you know what I'm talking about? You know what the little negative button is? Yep, that's right. So on my calculator, I wrote it down, just like I saw here. You got this, this is what you got. Got it. Type that in, just like you see, type that in. Oh, I did negative, not negative, I'm sorry. Type that in exactly like you see it. Good. Now, stay there. You can hit enter when you're done. All it's gonna do is not do anything. Now, to get it out of it, you have to switch back to the float notation. You know how to get to it again?
Yeah.
Second DRV. When it's at the top. What one do you want? Was that chick that does, the insurance commercials? Yes, that's who you want, Flow. Take Flow and hit equals. And look what it does for you.
0, 0, 0, 0, 0, 0.
Yeah, how many zeros did it have on there?
9, 8,
9?
9,
Well, after the decimal, was it 9, what you said?
8.
It should be 8.
4, 5, 6, 7, 8. And 2. What do you think comes after this? Why do you think it stopped there?
0.37? Or just 37?
Right, it'll be 37 after it. So your calculator ran out of digits.
Oh, round down like.
Okay, so you can switch between the modes here to get these different things. Do you follow me? Let me see if any surprises await here. I don't think there are any, but let's take a look nonetheless. Remember, it's 7 questions, 1 through 7, and then questions 1 through 7 again. So yeah, we can do all this. You just do that on your calculator. I just want to see if any of these are going to surprise you. When you see moles per liter and stuff like that, they're usually speaking of the ideal gas law. Have you guys heard of that? It's a temperature and pressure in a closed system are related by the ideal gas law. Let's go to speed. All right, now let's try to get these. So you're going to go switching in and out between scientific notation and not. So use your calculators to get you these 2 answers. Okay. Remember, you're going to have to switch between flow and psi, depending on your need.
So it's this 0.96.
Did you get your calculator told you that? Mine told me 10 to the negative 6.
How many times 10 to the negative 1? That means
So how many zeros were in that one? 0 point, and there were 5 zeros after the decimal.
4, no 1.
That's why it's messed up. Put the 5th one in, you should get the right amount. Now on the last one, you can type it in just like that. You can even just put yourself back into float notation and type it in just as you see it, and we'll simply multiply it as it's supposed to. So what'd you get for the second one? Anybody? 260,000, right? My first one gave me 8.96 times 10 to the negative 6. Anytime you see negative exponents, you know you're talking small numbers.
We can notice one decimal, put one digit, and then the rest. And then down here, you simply move the decimal 5 places, is what that's equivalent to. That's all I have for the section. So it shouldn't be that big, it shouldn't be that big of a deal for you, just let your calculator do the work for you, that's the point of the thing. Oh, let me have my calculator back. Should write it on that. Read. Yeah. Some teacher left it on the desk and never get it back. So you can have it. Sure. See you guys Tuesday. See ya. Did you want a pencil, electron? Anybody want a mechanical pencil? Mechanical pencil?
The boss wants me to give them out.
All right. She wants, give you a big sheet and bags. Give them out.
You too. Oh, let me cancel this. Where'd you go? There you are. Stop the recording, stop.